All right, so the last part we're going to look at is section 3.3, part 2. All right, so we've already learned the reciprocal identities. That's where you take a function and flip it. The quotient identities, that's like sine over cosine equals tangent. And the last three we're going to look at are called the Pythagorean identities. Okay, and there's 3 Pythagorean identities. Okay, the reason they're called Pythagorean identities is because they have things in them that are squared. Okay, 2 things that are squared, and then a number on the other side. Okay, and the first one is sine squared plus cosine squared always equals 1. Right, and that you could try it on the calculator yourself. Try it for any angle. Take the sine of an angle, square it. Take the cosine of that same angle, square it. I guarantee if you add them up, it always comes out to 1. Okay, so that's 1. Okay, the second one is 1 plus cotangent squared equals cosecant squared. Okay, and our last Pythagorean identity is tangent squared plus 1 equals secant squared. Okay, as far as basic identities, you now have them all. The reciprocal, the quotient, these should be with the other ones. Yeah, these are all the basic identities. And that's it. So these are the only 3 new things we're going to see today. Okay. So last night, what you guys really did in the homework is you didn't really simplify identities. You verified identities. Okay? Verify means just what you did. You started with something on the left. They gave you the answer on the right. And you showed that they were the same. Okay, so I'm just describing what verify means. They give you something on the left, they give you something on the right, and somehow you got to show that the 2 sides are the same. That's what you did last night. Okay, simplify is a little bit harder. With simplify, they give you something on the left, and they just say simplify. They don't actually tell you what you're supposed to get. Okay? It's nice when we know what we're supposed to get, so then when we get that, we know we're done. Okay? So on the test, it's going to be set up as verify. You'll start with something, and I'll tell you what I want you to get. You'll show me how. Okay? Just like all the problems we went through. Generally, we start with the more complicated side. Okay? You don't start with the simple side and make it look more complicated. Start with the more complicated side and make it look simpler. Generally, I put the more complicated side on the left and the simpler side on the right. We'll come back to that identity in a second. All right. So I want to just look at this first identity. Sine squared plus cosine squared equals 1. Okay. I'm going to subtract cosine squared from each side. I'm going to subtract it here, and I'm going to subtract it here. What happens when I do cosine squared minus cosine squared? It cancels out. What's the only thing on the left now? Sine squared. And what's on the right? 1 minus cosine squared. This identity is exactly the same as this one. The only difference is you've moved things around. Okay? So when we're solving a problem, we might have to notice that. We might end up with a problem like this, where it's very, very similar to what I gave you. Things have just been moved around a little bit. Right? Just like when you solve an equation. X plus 2 equals 4. Well, we move things around to solve it. Subtract the same thing from both sides. That's all I did here. Subtract the same thing from both sides. Okay, so any question why these two are the same? You can do it with any of them. You could -1, put that on the other side. There's all kinds of ways to rearrange them. But these do not work with higher powers. You can't say sine cubed plus cosine cubed equals 1 cubed. No. These only work exactly what you see right here. Okay, powers of 2. That's it. All right, so now that we know these identities, don't assume every single problem is going to have these in it. Okay? None of the ones from last night did. Okay? So not all problems are going to have these. Some will, some won't. All right, and let's try this one. Right, so it says verify. Verify means they're going to give me something complicated on one side. They're going to give me something simple on the other. And I have to show that they're the same. All right, so let's start by doing something that we pretty much try on every problem. Okay, what would be a good first step?
Change it all sine and cosine.
Let's change everything to sines and cosines. Leave that. What is cosecant? 1 over sine. Should I change cosine squared? Or is that already sines and cosines? It already is. Leave that alone.
We can put that over 1.
Yeah, if you want to put it over 1, you can. It's not necessary, but you can. Okay, look at the part that's to the left of the minus sign. Okay, that's one part here. What happens here?
They equal 1 or cancel out.
Signs cancel out. What's 1 divided by 1? We get 1 minus cosine squared. Okay, let's go back and look at our identity. Okay, actually the way I rearranged it. What is 1 minus cosine squared? It's sine squared. It's the first Pythagorean identity, just rearranged. Okay? 1 minus cosine squared equals sine squared. So I can change 1 minus cosine squared to sine squared, and that's exactly what I was supposed to get. And that's it. Right, because that's an identity. That's a Pythagorean identity. Okay? Just like here, when you wrote cosecant is 1 over sine, you just write it? Yep, you just write it because it's an identity.
So 1 minus cosine squared is sine squared?
Yep,
Okay.
it's this identity, just rearranged a little bit. Okay. Does everyone understand what I mean by rearranging that? Okay? And that's it. That's the first one. Any question on that?
So would our answer be that, or would our answer be 1 minus cosine squared?
So your answer is showing this work.
Oh, okay. So you don't want to know like this.
Because the
Okay.
answers are.
Yeah, I already know the answer. That's the answer you're going to get.
Got it.
Okay, I want you to show me how this somehow just comes out to that.
Got it.
Okay, so the answer is your work. I got to see your work. Okay, any other questions on this one? Okay. All right, I think we've seen this type of problem before. What's a good strategy to try here? Distribute. Okay, don't worry about necessarily simplifying everything at once. Just distribute it. We have secant on the right. Forget about that for now. Hopefully that's what we get when we're done. Okay, just distribute, see what you get. So sine times cotangent plus what's going to come after it? Sine times tangent. Now, every problem that I give you, I've done out, and I know things cancel. Okay, so things will cancel out. Okay, what should we try next? Yeah, let's change everything to sines and cosines. Okay, leave that. Dakota, what's cotangent? Cosine over sine. Now, some people might get real excited here. Oh, we can cross these out. We can, but we'll come back to that.
You know how excited we get.
You know, this is exciting. All right, sine, we're just going to leave it. And what about tangent? Sine over cosine. All right, so what can I do? This plus sign separates it into two problems. Don't mix stuff that's over here with stuff that's over here. These are separate. Okay, let's focus on this. Okay, what can we do here?
Cancel the signs.
Can cancel the signs. And that's it. That's all that ends up canceling out. You can't cancel across a plus sign. That doesn't work. Okay? So all we have on the left is cosine. Okay, if you want to put over 1, you can. Plus, what's going to be my fraction on the right?
Sine squared over cosine.
Sine squared over cosine. Okay, so now at least we got everything in terms of sine and cosine. That's still not secant though. All right, what else can I do with this? You can't cancel across a plus sign or a minus sign. Yep. We can add them. Well, we'd like to be able to add them, but what do you need to add these together? Common denominator. Okay. Easiest way to find the common denominator, take the two you have, multiply them together. So what's my common denominator here?
1 plus cosine.
What is it?
1 plus cosine.
Just take the two that you have and just multiply them together, not add them. Cosine. Okay. The one on the right already has a denominator of cosine, so you don't need to do anything to it. How about the one on the left? What would I multiply? In a second we will, yes. How did you get that?
Multiplying it by cosine.
Yeah, you multiply top and bottom by the other denominator. Now we have a denominator of cosine. Okay, and somebody just said, what would we say, what's cosine times cosine? Cosine squared. Now look at the top carefully. It says cosine squared plus sine squared.
Equals 1.
I thought it was sine squared plus cosine squared.
Doesn't matter.
That's the same thing. Okay, anytime you add cosine squared, sine squared, doesn't matter the order, this whole thing cancels out, just becomes 1. That's Pythagorean identity number, well, 1. Cosine squared plus sine squared equals 1. If you don't recognize that identity, you're going to get stuck here. You're stuck, there's nothing you're going to be able to do. Okay. What's in the bottom? Cosine? Okay. And now my last step, what's 1 over cosine? Secant. And is that what they wanted? Yes. Secant. All right. So this one involved a few different things. Okay. One, you had to distribute. Change to sines and cosines. We found a common denominator, which then let us use a Pythagorean identity. Okay, so both problems we've done so far had a Pythagorean identity. Okay. Questions on that one? Okay. All right, so tangent plus cotangent divided by secant times cosecant. Okay, so somehow that equals 1. All right, so this is the kind of problem we get a lot of different things we could try first. We could try sines and cosines. Okay.
I feel like that's worked out with us in the future, like the past, so maybe in the future it will.
Maybe it'll work out in the future.
Yeah, I think that's
That's all I understand.
Yeah, so I think that's a good choice.
All right, let's try changing to sines and cosines and see what happens.
So that's just dead air means that it's not gonna work, right?
I'm not sure. I don't know.
Won't the top already cancel out?
No, because we're adding. If you were multiplying, you would get some stuff that cancels out. But remember, you can't cancel across a plus sign. Okay? So let's try sines and cosines and see what happens. Okay, so that's tangent. Okay, cotangent is going to be cosine over sine.
You don't realize how much you depend on glasses and
Okay. What's secant? 1 over cosine times, what's cosecant? 1 over sine. Okay, any questions on that so far?
things canceled out.
No, nothing canceled out
Oh, because the plus sign. Damn it.
because of the plus sign. Nothing cancels out.
I mean, I
Cancel
don't
the
need
plus
it.
sign.
Cosine,
Wouldn't the top equal one though? No.
Yeah, if you got a plus sign involved, that messes up your canceling. So
You can't cancel
Oh,
the denominator, so over the fraction.
Would it just be
No.
sine plus
Can't do that.
cosine?
well,
Cancel the ball over one.
there's not much we can do in the bottom. Okay, I'm not sure even changing to sines and cosines was in the bottom the best thing, but let's try it.
Damn
Can't you
it.
cancel out the sign?
Actually, you know what? I think that's going to be okay. Let's see what happens. What can I do in the top? Yeah. Okay, the bottom, we're going to leave the same for a while. And again, I'm not sure changing it. We might end up just changing it back to secant, cosecant. But let's leave it as 1 over cosine times 1 over sine. Okay, and as you're going through an identity, this is more realistic. You try something, you're not really sure if it's going to work till you get towards the end and you're like, okay, it either worked or it didn't work. Okay. What's my common denominator here?
Cosine times sine.
Cosine times sine. Yep. Cosine. And that's good because we have the same denominator in the bottom, cosine times sine. So maybe that's going to cancel out now.
Oh, yeah.
Okay, so this is my fraction.
How'd you get cosine times sine?
Did you multiply the...
Cosine
Sorry. That was really
times
I
sine.
didn't do it like that. I just got
Okay.
excited because I do something. I'm so sorry.
All right, now what do you multiply top and bottom of the fraction on the left by? Sine. You use the denominator that it doesn't have. Sine. Sine. What do you multiply top and bottom by on the right?
Cosine.
Cosine. Use the denominator it doesn't have. Cosine. Cosine. We're going to cancel this.
These are still gonna cancel out.
There is going to be some canceling, yep. What's sine times sine? Sine squared. What's cosine times cosine? Cosine squared.
That equals one.
Yeah, that was a good job, John. Okay, so
Oh my god.
all right. So now look at your denominator in the top. What is your denominator in the top fraction?
I see how you what is your denominator?
So you can cancel that from the bottom too, right?
Well, what's your denominator in the top?
Cosine times sine.
What's your denominator in the bottom?
Yeah, you cancel.
Okay, these just canceled out because they're the same denominator. Okay, anything else we can simplify?
The top equals 1.
So it's 1 divided by 1.
Identity thing.
Yeah, what's sine squared plus cosine squared?
1.
1. Okay. So our final answer, we're left with 1 divided by, what's 1 times 1? Okay. And what's 1 divided by 1? 1. 1. Okay?
Teamwork.
All right, so this time changing to sines and cosines, it did work fine. Probably the best way to solve it. Yeah. Okay, any question on this one? All right, so we got two more, and then this is our second to last one.
Just for Pythag? Oh, no, I've never. These are all Pythag.
Okay, what do we call these two things? When you have cosecant minus 1, cosecant plus 1?
Conjugate.
Conjugates. Anytime you have conjugates, it's always a good idea to multiply them together because things cancel out. Right? And then worry about what happens after that. Okay, but if you see conjugates, just multiply them and then deal with it after that. All right, so what's cosecant times cosecant? Cosecant squared. What's cosecant times 1? Cosecant. What's cosecant times negative 1? Minus cosecant. And what's negative 1 times positive 1? Negative 1. Okay, the right-hand side, cotangent, just leave it. That's supposed to be our final answer. Okay, what cancels out here?
Cosecant.
Plus cosecant, minus cosecant. So we get cosecant squared minus 1. Does anybody recognize what group?
That's our second one.
That's,
Yeah.
go back to your identities.
So cotangent squared.
Kind of
Kind of reverse.
Look at the second one. Does it look similar to it?
Yeah.
What's the only difference?
Just minus squared.
The only difference is it has the 1 on the other side. So what is cosecant squared minus 1?
Cotangent.
Because of identity number 2, it's cotangent squared.
So our final answer would be left like that.
That's our final answer, yep. Okay, so this one, all you had to do was FOIL it out. And once you FOIL it, you get a Pythagorean identity, and you're done. Okay, any questions on that one? Before we do our last one. Okay.
Whoa.
Oh my god. Last slide, guys.
All right, last one. Okay, it says 1 minus sine over cosine equals cosine over 1 plus sine. They almost look the same, except kind of flipped and then make a positive and negative. Okay, so my suggestion so far has been to start with the side that looks more complicated. Which side looks more complicated here?
About the same. 1 plus.
About the same.
Yeah, there was.
Yeah, about the same. So it doesn't matter which side you start with. Okay, we could just start on the left. Okay, so forget about the right. That's our final answer. Start with the left.
Is it 1 sine and 1 plus sine? Oh, never mind, there's an equals.
Well, these are conjugates of each other, yes. So what might it be a good idea to do here? Use what?
Use the conjugate.
Use the conjugate. Okay, we can't change to sines and cosines. We can't add 2 separate fractions together because we don't have 2 separate fractions. The only thing we can really do is try multiplying by the conjugate. What's the conjugate here? 1 plus sine. And by multiplying by the conjugate, we're introducing something that should be in the final answer. So that's probably the right way to go.
We're allowed to do that with the top.
You can do it with the top. We usually don't, but this time we're going to try it with what's in the top. Okay. Any question on how we got the conjugate? All right, let's multiply out what's in the top. Okay, what's 1 times 1? 1 times sine? 1 times negative sine. Okay, those cancel out. What's negative sign times positive sign?
Negative sine squared.
Negative sign squared. Now, as a hint, don't multiply out what's in the bottom. You'll see why in the next step. Do not FOIL this out. Cosine times 1 plus sine. What is 1 minus sine squared? Somebody recognize that?
Cosine squared.
1 minus sine squared is something special.
Cosine squared.
Squared.
One, cosine 1 squared.
If I minus the sine squared,
Cosine
1 minus sine squared equals what?
squared.
Cosine squared. Okay, that's another one that if you don't recognize this Pythagorean identity, you're stuck here. You have to recognize this is cosine squared. Okay. So cosine squared in the top. We have cosine times 1 plus sine in the bottom. Okay. How many copies of cosine in the top? 2. How many copies of cosine in the bottom? 1. So how many can we cancel out? 1 from the top, 1 from the bottom. What am I left with in the top? Cosine. What am I left with in the bottom? 1 plus sine. Scroll back up. Cosine, 1 plus sine. And that's it. Okay, so as you're going through the problems, don't forget all 3 tricks. Common denominator, conjugates, change to sines and cosines. Okay. And use your reference sheet with all the identities, including the 3 Pythagorean ones from today. Okay. Questions on that? All right, so homework tonight, this one's in the book. Okay, starts on page 199, goes on to 200. 9 to 14 all. 19 to 27 odd, but skip 21. Okay, you don't have to do 21. Okay, tomorrow we will review in groups. Okay, and also tomorrow night I'll be putting a video online, an extra video, probably about 10, 15 minutes, showing you example problems that are similar to what's on the test. So if you have a chance to check that out, it might be a good way to spend 15 minutes studying for the test.